All right, in this video, we're going to talk about how to construct a prediction interval for the simple linear regression model. So our simple linear regression model is yi equals beta naught plus beta 1 xi plus epsilon sub I for I equals 1 to n. And we are going to be using this assumption that these model error terms are IID, normal, 0, sigma squared. Okay. All right. And a prediction using this model is y hat O or naught equals b naught plus b1 x naught. All right, this notation with the naught next to the y and next to the x, what I'm trying to indicate is that this isn't necessarily one of these I equals 1 to n type. It's not necessarily an observed index. Okay, so that's why I'm using this subscript O or a subscript naught. All right, so this is the estimated mean response at x equals xo. Okay, and this is also this is the predicted value of the response at x equals xo. All right, so we're not constructing a confidence interval for the mean response. We did that already in our previous discussion. Right now we are constructing a prediction interval, so we're looking at this more like a predicted value than like a mean response. Okay, but of course it is both of those things. So what's different though is right now we want to construct bounds for a single response, which is y naught at x naught. Okay, so instead of us trying to construct a confidence interval for the expected value of y, which is what we did previously, now we're trying to construct an interval for y naught, right? Which y naught is an unobserved or an unknown value of the response variable at x naught. Okay. So y naught is coming from up here, if you were to have an naught there instead of an I. All right, so let's see. If we were to, let's start with thinking about what y naught minus y hat naught is. Okay, so this is the difference between y naught and beta naught plus beta 1 xo. Okay, so this is this difference between what the potential value or what this unobserved value is, this actual unobserved value is, minus the predicted value. Okay, so this is kind of almost like a residual, except it's unobserved. If I want to calculate the variance of this, the variance of y naught minus y naught hat, this will equal the variance of y naught plus the variance of y hat naught, which we calculated this in our previous video for confidence interval. We found what that is. And then this variance of y naught, because we're using this assumption here that the model errors are normally distributed with variance sigma squared, and all this other stuff up front is constant, so y is also normally distributed with the variance of sigma squared. Okay, so this is sigma squared. And then previously, in our previous video, we found the variance of y naught hat to be equal to sigma squared times 1 over n plus x naught minus x bar squared over sxx. Okay, we can pull out a sigma squared here, and we get 1 plus 1 over n plus x naught minus x bar squared over sxx. All right. So this is the variance of this kind of unknown residual. Right? What about the expected value of y naught minus y naught hat? Okay, what's this expected value? This is the expected value of y naught minus the expected value of the intercept plus the slope times x naught, right? This is y hat, right? Okay, and of course the expected value of y naught, right? The expected value of y naught, right? If I were to take the expected value of this y, these guys are constants, and then the expected value of e is just 0, right? Because of this assumption where the mean is 0. So the expected value of y naught is just the intercept plus the slope times x naught. Let me go ahead and write that down. The intercept plus the slope times x naught minus, okay, the expected value of b naught is unbiased, so that's beta naught, plus the expected value of b1 is also unbiased, so that's b1, or beta 1 times x naught. And we notice that these guys are exactly the same thing, being subtracted from each other, so they cancel out and you get 0. Okay, so we're left with this conclusion that y naught minus y naught hat, this unobserved residual, this difference between an unobserved value and its predicted value, this is normally distributed with mean 0 and standard deviation sigma squared 1 plus 1 over n plus xo minus x bar squared divided by sxx. Okay, it's normally distributed due to that normal distribution assumption for the model error terms. Okay, and I can standardize this. Let me go ahead and use different colors. So y naught minus y hat naught divided by 1 plus 1 over n plus x naught minus x bar squared sxx. When you're standardizing, you're dividing by the standard deviation, so you need to take the square root of all of this. Okay. This will be normally distributed with mean 0, standard deviation 1. Okay. And since I don't know what sigma is, right, I'm going to need to use the estimator s, right, which is the square root of the squared residuals divided by n minus 2, right? So when I plug in s for sigma, I'm left with y naught minus y naught hat divided by s, right? I've plugged in s for sigma. 1 plus 1 over n plus xo minus x bar squared divided by sxx. This is now a t distribution with n minus 2 degrees of freedom. Okay. All right, so now I could construct a probability statement, right, where it's a t distribution. I have 1 minus alpha is my level of my confidence level, alpha divided by 2 in each tail. And my probability statement will look something like this, where I have the probability that we're between negative t alpha divided by 2, n minus 2. And then I have all this jazz here in the center, s1 plus 1 over n plus xo minus x bar squared divided by sxx. Okay, and then on the other side I have the positive t alpha divided by 2 n minus 2. Okay, this is going to equal 1 minus alpha, right? And if I were to solve this and rearrange this so that this value I don't know, right? This is what I don't know. I don't know what the value of y naught is. So I solve this for y naught, keep that guy in the center. I'll get my prediction interval. And my prediction interval, what it is let's see, it'd be y naught hat plus or minus t alpha divided by 2 times all of this s times the square root of 1 plus 1 over n plus x naught minus x bar squared divided by sxx. Okay, and this is my, and also we usually rewrite both t alpha divided by 2, and then we also write the degrees of freedom, n minus 2. Okay, so this is my prediction interval. Okay, so this is my prediction interval. And it's important to know, usually when you have a confidence interval, this piece over here, this is the standard error of whatever your piece over here is, right? And it's important to know that this is not the standard error of y hat naught. Okay, so this is not a confidence interval in that sense. That's why we call it a prediction interval. So rather, this piece here is the standard error of that unobserved residual, right? Y naught minus y naught hat. Okay.